Okay, so if we're trying to find f of g of the two functions, fx is log x and g of x is equal to negative 2 over x. So we're trying to find f of g at x. So that could be turned into f at g of x. So what we do is I put out my f of x, but for the x value, I insert the g of x. So f of x is log x and g of x is negative 2 over x. So if I combine them, putting the g of x into the x in the f of x equation, it becomes log negative 2 over x. So then what I would do is I'd start plotting points on the graph, simple points when x is equal to 0, stuff like that. And then once you do that, you can determine that the domain is x is an element of R such that x is less or equal to 0. So if we're trying to find the best equation to model these data points, we'd use a graphing technology such as GeoGebra. So first off, in their spreadsheet on their program, we can put in points on the graph and plot the points, and then we can use a application on the software that is called two-variable regression analysis. And so then a little menu will pop up, which includes a drop-down menu of all the functions. So it has all the functions, and then once you're in there, there's a little variable on GeoGebra. It's an R. So once you drop down for, say, linear, it will give you like a number, a decimal number. So for example, 0.96, and this is corresponding to how well the function or equation fits the points. So, and then you can do that for quadratic, other things, cubic, and then once you keep playing around with it, you can see the closer the number is to 1, so the higher the number, it's the best fit for the point selected. So, and if you have a number of 1, that means that it is exactly. So, for example, if you had a set of points and you put down a linear, you dropped it down to linear and had 1, that means the points you selected is a linear equation.